In this video, you will learn how to use different types of formula to represent organic molecules. The formula used most frequently in our videos has been the displayed formula. This is because displayed formula provides the clearest visual structure of an organic molecule. Here is the molecule butene, showed in displayed formula. It shows all the atoms in the correct order with lines to represent all single and double covalent bonds. Drawing all the bonds for very common molecules can be quite repetitive. For example, here is butanoic acid in its displayed formula. Since this is a common molecule, and as chemists we are clear with the bonding arrangement of carboxylic acid functional group, we also use structural formula to represent organic molecules. Here is the structural formula. As you can see, the covalent bond between the OH is not showing, as we know this arrangement anyway. In fact, we could simplify this further and remove all the displayed bonds like this. Structural formula is often used when writing equations, but the formula doesn't mean that it's always clear what arrangement bonds are in. Here is another example. First, the displayed formula of propane. If we then take out the lines representing the covalent bonds and group our atoms together in order they are arranged, we make the structural formula of propane. Pause the video now and try and draw both the displayed formula and structural formula of pentane, which has 5 carbon atoms. Here is the displayed formula of pentane, and here is its structural formula. Molecular formula is another type used and shows us only the number of each type of atom in the compound. To work out the molecular formula, you simply add up each type of atom. For example, here is the displayed formula of hexane. As you can see, it has 6 carbon atoms and it has 14 hydrogen atoms. The molecular formula of hexane is therefore C6H14. This alone is not very useful, as it does not show us how the atoms are arranged and where the bonds are. If you look at these molecules, they all have 6 carbon atoms and 14 hydrogen atoms. Although you may not be able to name these different molecules, you can see they are very different, but all have the same molecular formula. This is the molecule glucose. Pause the video now and complete the molecular formula for glucose. You should have counted 6 carbon atoms, 12 hydrogen and 6 oxygen atoms, so the molecular formula is C6H12O6. Sometimes the formula is reduced even further to make an empirical formula. The empirical formula is the simplest whole number ratio of atoms in a compound. We need to find the highest common factor, that being the largest whole number that is a factor of 6, 12 and 6 in this example of glucose. They all divide by 6. And so if we do this, we get C1H2O1. We don't show the ones, and so the empirical formula is CH2O. Although empirical formula doesn't show us the molecule or how it is arranged, it does tell us the ratio of atoms in the molecule. Now, at the end of this video, you should understand how to draw organic molecules in displayed, structural, molecular and empirical formula.